Good morning. I'm Christy Thomas, the Queensland Community Ambassador for the Cure for Cystic Fibrosis Foundation, and today I'm here with Professor Marc Pellegrini from the Walter and Eliza Hall Institute of Medical Research. Good morning, Marc.
Good morning. Lovely to be with you.
And great to chat with you again. I know that you're an expert in infectious diseases and immune defense, and that your particular focus is on chronic infections. And today we're talking about how all of that applies in a cystic fibrosis context. I know that you've been doing some fabulous research with B-Cepacia, and now you're planning to investigate another CF-related bacterial infection. Drum roll, please. What is it called?
It's called Pseudomonas.
Pseudomonas aeruginosa in particular.
Thank you.
That's all right. As a CF mum, it's certainly a name that we become familiar with quite early because it's one of the most common bacterial infections found in people with CF, and it can cause significant decline in lung function and be quite difficult to eradicate, which I guess is where that fit comes in with you and your chronic infection expertise. Could you briefly explain this latest research that we're announcing and that you're working on?
Yes, so Pseudomonas aeruginosa, and actually the whole spectrum of the pseudomonal bacteria, they're a tricky beast primarily because they become resistant to antibiotics pretty quickly. And they generally need pretty heavy-duty antibiotics. So we've been focused on trying to engineer new ways to get rid of these particular bacteria. And I suppose the learnings that we got from our work on B-Cepacia really set us on a train to be able to deal with this particular new bug. Well, it's not new, but new to us in terms of trying to identify treatments, Pseudomonas. And so the learnings we're actually starting to apply to Pseudomonas, which is probably a slightly trickier organism. So with B-Cepacia, it is incredibly important for that particular bacteria to live inside our immune cells. So it actually multiplies inside immune cells. It doesn't particularly like to live by itself, as opposed to Pseudomonas, which is reasonably happy living by itself, living inside the lung linings. It doesn't necessarily need to live inside cells. But one of the really weird things is that there is an immune cell which tries to kill Pseudomonas, but it doesn't do a particularly good job at doing that. In fact, when it tries to kill Pseudomonas, it actually kills itself. The cell kills itself. And in doing so, it releases a whole lot of proteins and enzymes that make the lungs really sticky and compromise the ability of the lungs to work, which actually obviously would compromise a CF lung much more so than a person that doesn't have CF. And so we find that these particular cells that are trying to do the good job are actually causing more damage than good. And these particular immune cells are called neutrophils. And so from our learnings with B-Cepacia, we found that we can actually start to kill these cells. And in killing them, not only are we stopping them from releasing all these dirty chemicals and enzymes that can damage the lungs, but in killing them, oddly enough, we're also destroying some of the bugs as well, so the Pseudomonas. And so we're finding that the drugs that we were establishing to kill or to treat B-Cepacia are actually translatable to also treating Pseudomonas infection. And we're currently, in the next year or so, pursuing this quite avidly because we think this is could be a particularly big game changer. Now, to put it in perspective, we're still doing a lot of sort of basic experimental work, and it will take us a good year to understand whether we can treat this bug adequately with the same sort of therapies we were using for B-Cepacia. But you know, we're obviously particularly passionate about this, and in ourselves we're tremendously confident that we're going to get it to work, but whether it will translate to a new therapy or not, that still needs to be seen.
Okay, so where do you see the project being 12 months from now?
We'll certainly have a lot of data in what we call preclinical data. So we would have established our models, tested it to see whether it's working or not. We'll have all that data there in place. The real sort of, I suppose, after a year's time, when you've got all this data, what tends to happen is you need to start deciding, well, can we go into a clinical trial? And that's when you sort of need a pharmaceutical company to support you and to say, yes, we're happy to give the drug. So these are all, at the moment, drugs that are being used in various different guises of cancer therapy, oddly enough, but they're actually not your traditional cancer drugs. They're very, very specific. They're targeted to kill abnormal cells. And we've always said that a cell that's infected with B-Cepacia, or indeed a cell that's trying to kill and not really doing a very good job, Pseudomonas, they're all abnormal cells, and we're killing those cells. So we're doing it incredibly specifically. We're not causing collateral damage. So yeah, if we get all the data in a year's time, then we certainly can start to talk to the pharmaceutical industry about maybe running what we call a proof of concept or a phase 1 clinical study to see whether these drugs could be useful as adjuvant therapy to people that are refractory to antibiotics.
I love that you're starting with that end in mind. You know that it needs to take that next step to get into patients' lives and making a difference. So thank you. I know that you've never worked in the CF space until recently, but this will be your second project funded by Cure for CF in the last 12 months. Does that mean we can add you to our official ambassador list?
Oh, I'd love to be one of your ambassadors. Absolutely. From my perspective as an infectious diseases physician, I always look at my research in saying, well, where can I create the greatest value for people? And obviously, I've taken on board a whole lot of different infectious diseases to see how we can add value, how we can improve people's lives. And the research that we're doing, we're trying to say, well, how can we apply, as I said, I keep using this phrase, our learnings, and that's what science is. You basically go out, you do experiments, and you learn. So we've learned a lot of things, and really the most important thing from my perspective is understanding, where can I apply this? How can I use this to change a particular disease, treat a disease? And absolutely, I mean, we found that a lot of the stuff that we're learning, a lot of the experiments that we're doing have actually pretty good application in people with CF. So I'd be incredibly honoured to be part of the group and be one of your science ambassadors. Absolutely.
Well, your scientific rigour and your passion, they're definitely assets to all of us here in the CF community. So thank you very much for your time, Marc, and we will be excitedly following your work.
Thank you very much.